Give me a computer strong enough, and I will solve the universe. Welcome to Agile Data Sites. CERN has just released 300 terabytes of particle collision data to the public. This is the same data which eventually led to the confirmation of the existence of the Higgs boson, the missing particle in the standard model of physics. With this data, you could conceivably derive the signals from yet undiscovered particles. This is what big data look like. It's an almost impenetrable wall of ones and zeros that hides within it unimaginable meaning if only we knew where to look. And it's gotten easier than ever to look. You could spin up an AWS cloud instance right now and begin blasting away at this CERN data with more computing power than was available to physicists in the entire 20th century. There's a Nobel Prize lurking in that pile of numbers, and all you have to do is load Hadoop on a powerful enough cloud and wait for the lightning to strike. There's more useful data in the world right now than in the rest of human history combined. The biggest difficulty is figuring out what to do with the data once you've collected it. In the case of CERN, it means getting rid of a lot of data. When the LHC smashes particles together, it immediately gets rid of 99.999% of that data using an algorithm. Then another piece of software reduces that data from about 40 million events per nanosecond to about 200. All of that means that CERN only retains about 0.0000005% of the data that is produced. This may seem like an isolated case, but it's not. Big data has an inherent weakness in that there are bound to be false positive signals on account of the sheer volume of possible correlations we can look at. The storage required for big data may be astronomical, but the real work is in the computation that it takes to make meaningful conclusions from that data. You might think that the cloud is the best place to work through large data sets, but you may want to run the numbers first. Computation on the big data scale, that of terabytes and petabytes, requires a huge number of processor cores to work efficiently. Since cloud costs are computed based on the number of clock cycles, it becomes incredibly cost prohibitive to run big data calculations on the cloud. Sure, if you're planning to run one-off data sets, maybe it's cheaper to go with the cloud rather than purchase hardware. But in most other situations, it just doesn't make economic sense. That's where Agile Colocation, like Agile Data Sites, can help. Let's say that a company is planning to run a huge data set, but only for a few months. They would need reliable power and cooling. They could build all of that infrastructure on site, or they could move into an Agile Colocation facility for a short-term colocation contract. They could quickly spin up their servers and run the computation for those 3 months. Then at the end of that term, they could pack up their bags and leave, having spent a fraction of the cost of the cloud without any long-term contracts. Or maybe after 3 months, they need 5 more racks. And 3 months later, they need 10 fewer. Agile Data Sites and other flexible data center spaces can help to facilitate that kind of rapid deployment and rapid decommissioning cycle. This can greatly influence your bottom line. It's one thing to collect data. That's happening at a rate unseen in the history of the universe. It's another thing to use that data. Just like the researchers at CERN, you are going to need to sift through a world full of data to find the one conclusion you've been looking for. Be sure that you have enough power to find it, and don't get sticker shock when you realize how much it cost you. That's all for me today. As always, stay centered.